I'll be starting right now, and thank you for joining us here at our Kickstart workshop. Let me share my screen first. So, okay. This is going to be the last session for today, for today's Kickstart. And my name is Mohammed Tanash, and I am an HPC application specialist working at the Holland Computing Center. And today our session will be talking about running and submitting jobs on HCC resources. So I will do, I just do my split screen so we can use both our slides and working on the terminal as well. I will close this one, sorry for that. Okay. Let me go with this bigger maybe. Okay. So we learned about, like shell lessons and some commands about, how to use our terminal. On the other hand, we get also some information about our resources for the second session. For the third session, we got like some information and techniques about how to transfer data and about our storage systems and how we can use it. So now we will go to the next part, which is there's an applications. So installed actually in our resources, in our clusters, Crane and Swan. And we want to know how to use those, softwares and how to submit jobs on our HCC clusters, which is the main thing that we want to do actually, or most of the users, they do for running their applications and their analysis and computations on our resources. So I just logged into to my account on Swan, and what I'm gonna do right now. So as you can see, when you log in, you get like those information about the storage, and you have logged into the Swan. So one of the commands is gonna be pwd, and in the pwd, so as you can see here, so I'm located at my home directory, so which is the default location that I will stand by when I first log into the cluster. And this is my group name, and this is my username. So when you log into the cluster, there is some applications that are already preloaded to your account. So you don't need to load those, applications. And remember that every time you want to use one of the applications or run of, jobs using some of the applications, you need to load those to your account. Every time you log out and you log into the cluster, those applications is not going to be automatically loaded to your account. You need to reload those applications to your account every time. And how can I know that? Like in this case, like we'll know how we can do that, or how can we know those all the applications that we want to use is already loaded. So when I said like it's loaded to your account, that means the paths here, as you can see, the paths and the library paths for those applications is already set up to your paths, or already added to your paths. And if we can do, for example, as you know, like echo is a command that will show you or print the stuffs, right? So if I want to do like print all of the path that is already assigned to my account, so I can do that. So I can do echo path, and let me do clear first. So if I do echo path, so as you can see, here's all of the paths that are already assigned to to my account or added to my account. If I loaded another model or another application to my account, so that the path of that application is going to already be added as well to my account, as well as for the library paths as well. So if I do echo LD or loading library path. Okay. Then all of those also libraries, paths already, it will print all the ones that already added to my account. So I can check with those. So it's just like for the information. This is not necessarily to do for yourself, like, just for checking and just to explain to you what's going on when you are using one of the applications and submit jobs to our cluster. So when you load any of the applications, as I mentioned, so the path of the application is going to be added to your current path. The other thing is I want to talk is about hierarchical structure. So some of the modules, like for example, there are some modules like for example, like they need some other modules to be preloaded before you can load those programs, because they are prerequisites or dependent on those applications. So in this case, we use like hierarchical structure, which is you can imagine it's about like kind of tree. If you want, to load one of the leaves, you need to, load the the parents of those, leaves, and able to reach out or to load those modules. So some of the applications needs, some prerequisites and preloaded applications, and able to load those applications to and load them to your or add the paths to your current path. And we will see how we can, do that. It's pretty easy, and it's not complicated to do that. Usually, like in our, applications, there is like a name. Every application has its own name, and we use always like a lowercase names for the application. So if you want to load one of the modules or one of the applications, to your account or to your path, to add it to your path, and you need to load those modules and using lowercase. And what we usually do, we use for example, here is like if I want to load, for example, use like, for example, Python version 2.7, we usually do like the name of the software, which is Python, in all lowercase, and backslash, and then the version of the software or the application that you want to use. So how we can, load those, applications and in order to use them, because if I want to submit a job and that job needs to, load one of the applications, we need to use that, module to add it first before we can use it in our system. So there is, an application called like Almod, or module system. The module system is, responsible to load those applications and able to load those paths to your current path, and and able to use those application. You need to load those using the module system. We will talk more about it in in the application session tomorrow, but I think it's very important to know about this today, because you need to use it on your submission jobs on the clusters. So the first command that we can use, which is module, it's module, like this is the or the fixed command that you need to use, which is the module system that we need to use. And for example, if we use there is a command called module avail, and the first command, module avail, if we do this command, it will show us all of the modules available on the system. So as you can see, we have like tons of applications and softwares that's available in our system. So if I want to use, for example, one of those commands, so I just one of those applications, I need to do a module load. But it's very hard to search on all of those list of the available applications in our cluster. So to do that, there is an easier way actually, and sorry. Okay. I'm not sure what's going on here in my terminal, but we'll see. Okay. So here, there is another, for example, a command called module spider. Module spider, it will tell you, you know, the way how you, for example, you know, load the module, for example, or if it's the model is already exist or not exist in our system. So some of the, you know, applications that are not exist, and we need to, you need to request an, you know, install request form to fill out this form, and able to install this application to in our system, because it's not available maybe at this moment, but we can, you know, work on it and install it for you if it's if you need to use it. So there is another command, like for, as we said, this module. Sorry, my terminal is frozen. I'm not sure why, but okay, probably I need to relog into the cluster. Okay, here you go. Not sure what was the problem, but so if we do module spider, let's do the example, the same example, which is Python, for example, Python, the version 2.7. So in this case, it will tell us if the, give us an information how to load this module. So the information, for example, this is the Python, and the Python 2.7. It's already, you know, available on our cluster. And if there is prerequisites for this, you know, application or this software, it's gonna tell us, like, you know, there's a prerequisites and some of the versions. I can do, for example, module spider Python itself without a version. As you can see here, it will list all of the versions, not just a specific version, but we can do as we did before, which is Python version 2.7. But here we can do as well as, you know, Python in general, and it can list all of the, you know, versions of the software that is that's already, you know, available in our system. And then there is like module list. This command will list all of the preloaded. As I said, there is like preloaded, you know, this command will list all of the available application that's already loaded to my account. And when we already, you know, echo the path over here, so those, all of the preloaded, you know, applications already, the paths, as you can see here, is you can find the paths of those applications, in the path already preloaded to your current path or added to your current path. So we can, you know, for the module list, you know, we can see all of those, you know, or loaded application to my account. Any added application, if you add any of the new applications to your, you know, load any for the new applications, is gonna, you can see it as well. When you do module list, you can see it added to your, you know, model or applications in your account. So we will do module list. So we will talk more about it tomorrow, about those things. But like, so this is all of the applications already preloaded. So if I want to load any of the application, I need to do the module, the command module load. Module load will be responsible for adding a new application to your system, or to the path, or to your account. So in this case, if I want to, you know, add any of the applications, so I need to do module load and the name of the application. I can do, for example, do Abacus, for example. And if you load the model, so if you do this, so it will add it. The Abacus is one of the applications named Abacus, so I already added this one. And as you can see, if you do module list again, you can see the Abacus, it's already number 8. I had 7, and now another, you know, application being added, which is named Abacus to my, you know, paths and to the applications that I can use. So for example, I can do more than one application at the same time. If I do module load and now application number 1, then number 2. So I just like space separated. So I just need, you can list more than one application at the same time. But on the other hand, I can do also do, for example, Abacus, and then after that, just hit double tap, and I can see there is more than one one application available with the name of the Abacus, which is like there's multiple versions of this. So if I do just the Abacus, it's just like gonna load the most current one, which is the updated one, which is gonna be 2021. If I want different version, I need to specify this version, and I can see, for example, Abacus 2019 instead of 2021, and I can do enter. And here, as you can see, when you load this one, it will replace the current one, which is Abacus 2021, to the one I have specified, which is Abacus 2019. And that's how we can, if you do module list again, as you can see, the Abacus version is already now changed to 2019 instead of the most current one, which is 2021. So there is another command. If I don't want to use one of the commands, for example, Abacus, again, I don't want these applications to be loaded to my path, and I don't want to use this application, I can unload this one actually with the command module unload and the name of the application that I want to. For example, if I want Abacus, it's going to be Abacus 2019. And if I do module list again, to list all of the applications I already loaded, so I can't see the Abacus 2019 over here. So it's already unloaded. So, but we need to use this command is just you need to use the command module first, and module list is for listing, and module, load is for loading the module, and module unload for unloading any of the modules. I can, unload multiple modules, for example, at the same time. So if I do, for example, again, module load Abacus 19, and then I want to, if I do module list, there is, if I want to unload, for example, I can do unload module, for example, Abacus 19, and for example, pair. So I can do those together. So if I do this, so it's going to be unload 2, and I can do 3, 4 as at the same time. So in the load command is going to be the same. So you can load more than or one module at the same time, and you can unload more than one module at the same time. So sorry, I'm sorry, I do unload module, so it's going to be module unload. So then if I do module list again, so as you can see, you can't see anymore like Perl or Abacus. So if I do module load, I want again to be Perl, so I can load it to my module again. So there is another command called module purge. So like if you have, for example, loaded 20 modules at the same time, and you want to unload all of them together, so there is a command called module purge. So from the name, purge is gonna what? It's gonna clear all of the models and the paths in my current account. So if I want instead of lists, unload and list all of the models that I have, so module purge is gonna unload all of it together. So module unload or module purge is gonna remove all of the modules, which is the 8 modules that I have at the same time with one command. Also, again, anything we want to more information, I can use module, which is the command -- help. So it can give me all the options that I can use with this command. So again, available softwares. How can I know all the softwares? You can refer to those links for the available softwares that are already in Crane and not Rhino. Actually, it's going to be Swan. I'm sorry, it's going to be Swan. So this is going to be for Swan as well, and this is going to be for Swan. I'm sorry. So so this one is going to be like those links. It's provided in our documentation. You can find the list of all of the software or available softwares that are available in our Crane and Swan. Again, we will talk about more in details in tomorrow's session about the software and using the softwares, but also users are allowed to compile their own applications and even creating their Anaconda environment or creating their Docker or Singularity images. Also, on the other hand, if you need one of the applications, you can use our form with the provided link in the slide, and then after that you can fill out the the install application request, and we will try to install this or the requested application in our systems, enable for yourself to use it or other people who need it. So let's do some exercise as well, like just to make sure that you guys are prepared for that. The first exercise is like find a list of available modules. What the command that we need to use for this? So the command that we need to use is like module what? Module
list.
Module avail, which is module avail. It will list all of the modules available in our system. Load one. The second one, load one or more of the modules from the list you just found. Now unload them and try to do different ones two at the same. For example, if we do module avail, you will see all of the list of the modules. Just try, to load, for example, I load, for example, one of those applications. You can use whatever. So maybe I can use this one. And if I do it's always like hang up with the module avail. I don't know why, but because probably this is, it's lots of applications. Okay, so I can do what? I can do module load. Oh, sorry, this is a capital letter. The max 3.3. And if I do again, I can do, for example, another one or two. I can do two at the same time. So I can do Majoko, for example, as I mentioned. So you can choose whatever you want. Probably I'll use also this one. This is another application. So I can load. So I can load two applications at the same time. If I do module list, so look up the information. So if you do module list, you can see all of the applications that I already loaded. So again, number 3, look up information about QII ME2 module. So I want to use, this one. So can you guys like look at this and let's do module to look at this and how we can use it. We will need to use which command? Module spider, right? It will give us the information and all of the, for example, all the versions of this software and the prerequisites for it if it's available. So let's try now to load the model Espresso 7. Everybody's trying to load this model. If I do module load Espresso 7, this is an application called Espresso and the version 7. And as you can see here, it didn't load that application. Why? To know more information about it, so I need to do what? Module spider, probably because it needs more prerequisites, right? So let's see. The module spider, that needs the Quantum Espresso needs the compiler Intel 20 and OpenMPI 4.1 to be preloaded or loaded first to your account, then after that, in order to load the Espresso 7, you need to load those applications first because they are prerequisites for the Espresso 7. And if I do module list to see if those applications, the compiler Intel 20 and OpenMPI 4.1 is already loaded, we will see here. So as you can see here, we have OpenMPI 4.0, but we don't have, as you can see, the compiler that we already have is compiler GCC, is not, the Intel one. So in order to be able to load the Espresso 7.0, so I need first to load the compiler Intel. So now I loaded this one, and then after that, if I do try to module load the Espresso 7, it's already loaded, as you can see. Module list, let's see if it's loaded. So I can see the modules, the Espresso 7 application is already loaded in my account. So unload all the modules with only one command. What the command is needed for that? It's module purge. Module purge will unload all of the modules at the same time. So this command, so if I do module purge, then after that, if I do module list, nothing, no module loaded. So because we already, unload all of the modules at the same time. Now we'll talk about the running jobs. So there is a very important thing that you need to know always. If you are running jobs, so all of the outputs and input for your job needs to be allocated in your work directory, not in your home directory. As you can see right now, I'm right now in the home directory. So I need to change. What I usually do, I change, my location to my work directory. If I do PWD right now, so I'm now in my work directory, because if I want to submit jobs, your input and output files need to be in your work directory. It can't be work in your home directory. And the reason why, because the working node, which is where is your job is running on right now, or when you submit your jobs, is not gonna be accessing your home directory. It doesn't have the access to your home directory for read and write. For writing, it's not writable. So the worker node, when you submit a job, if they need to write the output of your current running job, is not going to be accessible for your home directory, but it's accessible for your work directory. So it's very important. So if you try to submit a job while you specify the output is going to be in your home directory, your job is not going to be running. It's going to be killed, and you will get an errors, and is not going to work for you. So able to do that, all of that or like input and output needs to be in your work directory. So this is very important, and remember it all the time. The other thing is, like, now let's talk a little about the structure of the HPC, so you can understand how it works when you are running jobs. So in the HPC, when I log in right now, for example, I logged in here, right? So we are in the work directory. Actually, we are logging to the login node, and the thing is, when you are doing commands, you are running it on the login node. So the thing is, when you submit a job, so the structure of the Swan or Crane, any high performance computing computational resource that have something called worker nodes, that they are the nodes, like it consists of several nodes, 100, 20, 110, whatever is the size of the cluster. And then after that, and it's connected to the storage where you can save your data, as well as to the login node. So when you submit a job to the cluster, you are not submitting it, you are not running it on the login node, so you are running it on the worker nodes. That's why when I said you need to be in the work directory, because those worker nodes don't have access to write your output on the work directory and the home directory. It has just the ability to write it and read it from the home directory, from the work directory. I'm so sorry. So that's why, like, when you submit a jobs, it goes and allocate those resources to your job and run your job on those, worker nodes, and the output is going to be written to your work directory. So that's why it's very also important don't run your jobs on the login nodes. And if you run your jobs on the login nodes, your job is going to be killed, and you're going to be affected because you are affecting our resources. So because when you are logging to the login nodes, that means like it's a shareable resources that everyone, when they log into the cluster, they log into this current node, and everybody is using it at the same time, which means that if you run your jobs, that means you are consuming the resources on the login node. That means you are affecting the login node, and probably, like, if your job is very extensive computational thing, is going to maybe break the login node and break the cluster itself. So in this case, if you want to run your jobs, you need to run it on the worker nodes, and we will see how we can do it instead of running your jobs on the login node. This is a very important thing you need to know. Don't run your jobs on the login node. On the other hand, put your write outputs on your work directory, not using home directory. So Slurm, let's talk about Slurm. Slurm, like when you submit a job, Slurm is stand for Simple Linux Utility for Resource Management. So it's the software that is installed in our cluster, and it's the most popular resource management software that will receive your job and assign the resources for your job. For example, if I ask my job for 4 nodes, for example, like 20 processor, 20 CPUs, and 20 gig of RAM, when we submit our jobs, the Slurm, which is this, let's say it's a scheduler, it will take our job and assign those resources to my job. When the resources is available, then it will assign those resources to my job and reserve it to my job and running my jobs on those resources. This is what we use actually in our cluster. We call this Slurm, and this is scheduler or resource manager software is most popular and used on more than actually 60% of the top 500 supercomputers. And when you assign to the job, there's the Slurm, which is the resource utility management system, will take your job and allocate all of the resources that needed for your job. And when those resources allocated, it will assign those resources to your job, and your job is going to be running. If there is too many jobs on the system on the queue, then you need to wait till the Slurm will find those resources to your job and run your jobs on the cluster. There's two kinds of running jobs on the cluster. There is an interactive job and there is a batch jobs. And what's the difference between them? So in the interactive jobs, actually, you are reserved in the interactive job. We are reserved some resources from our cluster, and we are running our jobs, interactively. And you can run the command and you can see, the output directly. While on the batch jobs, you are submitting the jobs through, our Slurm, our system. And when those resources are available to yourself, again, your job is going to be submitted and running on those resources. But on the other hand, the difference is you can't see the output until your job is being done and finished running. After your job is finished running, so you can see two files, one file for your output and another file for the errors, if there is any errors happen during the running time. And you can view all the output of the running application on the output files at any time. So it's going to be saved in your work directory. Again, it's going to be saved in your work directory, because you need to assign the output to be saved in your work directory, because the worker nodes doesn't have the ability to write on your home directory. So interactive jobs, usually, if you need to to do programs interactively, like you need to run, command and see the output, run application and see the outputs, running in front of your eyes. While like the bad jobs, usually for the bigger or big jobs, that takes hours to run, and you need to see the outputs after a while. So today we will, learn about how to, run or how to use the interactive jobs, run some jobs in the interactive jobs and in the batch jobs as well. So first we will start with the batch jobs. To create a batch jobs, first of all, so right now I am in my work directory. Let me clear my directory here. And for the batch jobs, we need to create a file called, a job file. This file will include the information about my job and the resources that I need to my job. And it's very important to know how to write those, batch jobs and the job file. And we will specify the amount of, the number of the CPUs, the number of how much memory that we need to be assigned in our job, and number of nodes, as well as, the direction or the directory or the location of our input and output, etc. There is a command called SQ. That command, we will talk about it in near future. And this is to, monitor and to see the status of our job, if it's running, if it's pending, if it's completed, if it's killed. So we can see those kind of, status of our job. And there is the S account command. The S account is like, kind of, a database that will, give us information about, or statistics about our running jobs, how actual memory we used, when our job starts, when our jobs end, etc. So it's kind of, for monitoring our submitting jobs, those commands, the SQ and the S account command. So first of all, like the submit script. So to find, to create, now we're gonna submit a job using the batch on our Swan, cluster. So to do that, we need, as I said, like we need to create a job script that will, that we will use to submit the job in our cluster. So I can't do anything without this. So I can't submit the job without creating a job file or job script file and submit it to the cluster and able to, run any of the jobs in the cluster. There is a note, which is an important note that you need to know. That is, every job that you need to submit, you need to create, usually recommended to create a submit script file or a job file for that specific job. So if I have 10 jobs I need to submit to the cluster, so what usually I do, I create 10 jobs for, and 10 scripts or submit scripts for each job that I want to submit. Sometimes you don't need to, sometimes you need just, sometimes if I want to resubmit the same job, I mean, like what I mentioned, you create a submit job file for each job if it's a different jobs. If it's the same job, but some parameters are different. For example, instead of using the parameter 50, I want to use the parameter 100, for example, or I can do loop for submitting more than one job at the same time using the same submit script. So in this case, sometimes I don't need to create a new job file. But if it's a different application, I usually create a submit job script for each individual application that I use. So this is going to be in my record. I can refer to it, and also I can see in the future if there's something wrong happen with the job. I can see if there's something wrong with my submission job, so I can follow that. Again, what's the structure of the submit jobs? So, and how can I create it? So you can create it using any of the editor application, for example, Nano or VIM. And I'm sure most of you guys have experience and talked about and know how to use Nano. And for example, I already have one here is already called serial.sh, and I'm gonna show you guys. We're gonna download it again in the future right now, but like I'm gonna show it to you. I'll use, for example, Nano, or I'll use VIM. Let me use Nano and serial.sh. So this is the name of the submit script that I want to submit. I can name it whatever I want. So I can name it job one. I can name it, the name of the application, job one, whatever. You can even the extension can be, either like, for example, sh, which is script file, or .slurm, or like, it doesn't matter. So the extension usually is a text file, like, which is a bash script usually, and the extension doesn't really matter if you do it like .sh or .slurm. You can, already submit it to the cluster. So I already name it with serial.sh, and if I do this one, so okay, because I already okay, I need those preloaded application, because I need to load the Nano. It's already because we unload all of the applications, so that's why Nano command is not working with me right now. So as you can see here, Nano serial.sh. So Nano is already here right now, so I can use it. And I wrote those for those lines to submit one of the jobs, and we will do it together just after explaining this. So the structure of the submit script will be the following. So there is a bound, and explanation mark, \bin \sh, and this line is very important. You need to put it at the beginning. So you need to do it at the beginning of each submit script for any job you want to submit to the cluster. And this is, well, they call it the shebang, which is tells the the scheduler, the Slurm, what interpreter to use to read your file and interpret your file, which is going to be here is shell, which is bash, or the bash script. This will tell the Slurm this is a bash script, which is a submit file or a job file that we already want to submit it to the cluster. Then after that, there is the section. This section, the first section that we're going to talk about, it has some comments and and some parameters that we want to provide for the job script that we just created. The first one, which called, like, all of them will start with pound /patch in capital letter. So remember, bound /patch. Then all of those commands needs to start with pound /patch, and then after that we give them the parameter that we want to use. The first parameter that we want to specify, which is --time, which is how much or how long we need to reserve time for the job to be running. For example, I want to reserve a time for my job, for example, maybe an hour, maybe 2 hours, maybe 1 minute. And you can do it actually, up to maximum 7 days. So you can specify the time for your job for maximum to be running for 7 days. But remember that when you reserve more time and you don't need that time, your job is going to be, probably waiting more time on the queue to be running, because the Slurm, when it will take this file, it will try to find available resources for your job. And if you ask for 7 days, for example, for your job, that means you are asking a long time, and it's hard for the scheduler to find the available resources to be running for 7 days. So your job is going to be waiting on the queue for usually for longer time than if you request less time. But some jobs, if your job is really long and is really big, job and needs that time, so there is no problem to ask up to 7 days for your job. So how we can, specify the time? The first on the right is going to be the second, and the 10 here, the number 10, which is going to be the minutes, and the other, it's a column separated, and the number 0 is the hour. And if you want days, it's going to be like on the term of dash. So for example, it's going to be 7 days. It's going to be, for example, 7 dash 00 0000 is going to be 7 days. So if I want in hours, so I just can replace the 0 with, for example, 1 hour or 2 hours, whatever, and the minutes with the minutes and the second with the seconds. The other parameters, which is dash nodes. So as I mentioned before, so the structure of the high performance computing environment, it consists of nodes, several nodes, and each node has multiple CPUs and different amount of RAM. So usually, like, how many nodes you want to specify? If your job is a small job, it doesn't need that much resources, probably I need 1 node. If it's a bigger job and it's using, for example, MPI jobs, and we need to run in different nodes, I can ask for more than 1 node, maybe 2, maybe 3. Again, more resources you request, more waiting on the list, on the queue will be usually. Depends on the how many jobs are already submitted to the cluster. The other one, which is dash and task per node, which is how many CPUs you want to request for your job. For example, if I need 10 CPUs, if I need 1, if I need 20. So this is the amount of the CPUs that you need to specify for the job you are requested. And this is the number of the CPUs, and there's dash mem, which is stand for memory, and how much memory I need to specify for my job. For example, I need 10 gigabytes of memory for my job. It can be in megabytes, it can be in gigabytes, so it can be in kilobytes, but usually usually we use gigabyte, and the default is going to be megabytes. So if you didn't specify the gigabyte here, it's going to be in megabytes in default. So so if you need 10 gigabytes, you need to specify GB at the end of of the line. Also, this is a total memory, which is when you use, for example, Open MPI, and this is going to be allocated for all of the resources that you request. There is a memory per CPU if you want to specify a memory per every CPU. This is usually when you are requesting for more like MPI jobs, or for each CPU you want a specific amount of memory. You can even specify that amount of memory to be, for example, 10 gigabyte per CPU. The other one, which is a job name, if you want to name your job, so your job, for example, because for example, if I want to submit like 100 jobs, how can I specify them? So usually you need to specify the name for the job that you are running and give it a meaningful name. Depends on the application that you are running. So it's up to you. You can specify it with the name that you want. And the spatch -- error, which is very important. And this needs to be in your work directory. Again, this needs to be in your work directory because the worker node doesn't have access to your, writing and reading access in your home directory. So it has the access to write the output file in your work directory. So usually the error needs to be specified / your group or your work / your work directory, your group name / your username and the name of the file. So it needs you can put the relative or absolute path to your error job. On the other hand, the output, where's your output need to be, and what's the name of the output file? So you need to specify that as well, like in the output command. And usually we use the same name for your error and your output, and the difference is in your error is going to be .error and your output is going to be .out. So where can I see the output in my after the job is completed, is going to be in the file name .out. So this is going to be the output of my program after finishing. So if there's any error happening during the execution time, I can find or read the error in the .error file. So hopefully there will not be, but like many times, sometimes there's some small errors. So you can find this error in .error file in your work directory. So this is the first section or the second section after the bin bash. Then after that, this is the first section, which is specify the amount of memory, the name of the job, and there is actually more parameters we can specify here, and you can look at it later and you can get more information about, but those are the most important ones. The next section is going to be what's the module that I want to, what's the name of the application. We already talked about the module load, right? I need to load the module for my application. For example, if I want to use MATLAB, the version 2014, so I can specify module load MATLAB. After this section, so the order of this section is very important. You can't do, for example, this section before that section. So in order to be able to run the job, you need to be in order for the creating your job file. So after, if there's any other model loaded, so I can do 2 models, 3 models, whatever models I need, I can list them in this section. Then after that, the last section, which is the last thing I will put, which is the command for running the application. So when I want to, run the application, there is a command, right? I want to use to run this application. So you need to specify that, in the last section, which is usually the last line for your running job. The make directory here and CD, this is just like, since this is, a script file, this will go in order. So it will interpret your file or job file line by line in order, So it's going to load the model, it's going to CD, go to this, folder, and it's going to make a directory in this location. And then after that, it's going to run this command for your job. So usually this is going to be your last section for your submitting job. So let's see what we do here. Like we have the submit script bin bash. This is the second section, which is we specify we need 1 node, we need 1 CPU, and 10 minutes. We reserve for 10 minutes, 10 gigabytes memory, and our name job is invertrand. And the error file or the error here is the name of the error file that we want. So what I mentioned here, if you remember, I can do the absolute path. For example, I can do work and my group name, and then my username, and I can do this. So this will this error file is going to be saved in my work directory with the name serial.error. But here, as you can see, there is %J. This is a parameter that will, when you assign a job, we'll see it in a little bit. When we submit a job, there is like a number that the Slurm, we submit it to Slurm. Slurm will take our job. So in order for Slurm to manage this, it needs to give it an ID. So your job is going to get an ID, which is a job ID, and refer to your submitted jobs. And this is given by Slurm, by the scheduler. So if we do %J, that means the number here. So my error file is going to be named with the serial. Then after that, concatenating with the job ID. Here's whatever the job ID is going to be assigned to my job is going to be replaced with the %J. For example, if it's 1234, so my error is going to be serial.1234.error. Okay. This is how it works. You can just remove %J and do the name that you want. But for myself, for example, it's a good habit or good practice, to know the name of the job and the job ID that it's been running. So in this case, you can track the job and identify the job more accurately. For the output job is the same. So I have here the serial dot, the number of the job ID when I submit the jobs dot out. And here is just, we will load the model, the second section, we will load the module that needs, which is, we need the MATLAB, instead 2014, I need to 2020A, using the model load command. And then I create the directory in the temp. And then after that, I use the MATLAB command, which is, this is the command that I want to run the application, which is MATLAB dash node display dash R invert rand, and I give them the parameter 10 to the power 4, and then it's going to be quit. So this is the command. Every application has its own command. You have to be familiar with the command application that you want to use. So it's your responsibility, you know, to give those, you know, parameters and you know, commands for your application. So after I finish this one, I'll do Control X, and exit. And then after that, after I exit, so I have the serial.sh. So serial.sh, as you can see, it will use the other application. So this is how we submit the job, right? This is the submitting job script, as well as I have the application to be running. So this is the application I have for the serial to be used when running the job, which is invertRun.m. So I have my submit scripts over here. I have my MATLAB application that I want to use ready for submission. So as I mentioned, dash nodes, I already talked about it. How many nodes we requested, time requested, memory requested, number of tasks, number of the CPUs, and this is the memory port CPU, dash output, dash error, and dash job name. Those are the parameters that we use in our job file. There is more parameters you can use, and you can refer to the Slurm documentation or sbatch-help for those, you know, comments. Now, as you see here, like, you know, we ask, for example, 10 gigabytes of RAM and, for example, 1 CPU, and those are actually estimated ones. So how many or how much RAM or memory we need for our job, and how many CPUs we need for running our jobs, the absolute answer, we don't know. So it's usually like coming by experience. Maybe you can ask some people who, you know, who run the application before, and how, you know, the resources, you know, requested been, is it like memory bound or, you know, CPU bound more? So you need to figure it out, because nobody knows like the answer itself. But there is a good habit sometimes. Usually what I do, if I want to run a small application or an application, I do just a small job with, you know, small parameters, and try to run it using, you know, small resources, and see how it perform. And if it perform well, that means, you know, I can, you know, for example, do 3-4 times or small jobs, then after that do bigger and bigger, and you know, ask for more resources if it needs. But usually, you know, nobody knows the answer, but, you know, running a small test will help you to identify if it's memory bound or if it's, you know, CPU bound, you know, application. Again, so there's you know, those, I'm not going to talk about those, like this another additional options that you can look for, you know, your Slurm script. And this, for example, like dash begin or dash deadline. You know, if there is any, for example, mail, like it can mail for you, like when the job begins, when the job ends, it can, you know, send you an email with the begin and, you know, when your job is running. You can look more about those, and, you know, you can specify more options and for your dispatch if needed. Those are as well as you know, some environmental variables that you can use, and some of them that we already use. For example, you can use, you know, Slurm job ID to you know, specify the job ID that assigned to your job, and those are, you know, environmental variables you can use. You can because we are limited in time, so I'm not gonna talk about it a lot, but you can read it and you can, you know, use it if you want. So those are can't be used in the sbatch command. So in the sbatch, when you write the sbatch command, you can't use those, but like in the other commands, you know, other section, which is the section that you want to you know, run, you can, you know, use those symbols. Those are also replacement symbols. Like, for example, this is for %J, as we used it in the, you know, job name. That will, you know, for example, replace the %J with the job ID that assigned from Slurm when you run your job. So you can use also %A or capital or %A small. This is %U for username, for example. And you know, if you are using a job array, you can use %A for, you know, the master job allocation number for your job array, and -A small, %A small letter, which is a job ID, which is the index of your job number. So for example, here we use job percentage %J.out. This will replace the job number, which is job ID that is assigned. For example, if it's assigned 7773455, this will be replaced by the %J in your output file. I'm sorry for that noise if you guys hear it. This is from outside, so it's not from my place. Never mind. So there is a advanced Slurm options. So for example, if you are running an job array, you can use -- array and the array numbers range. For example, 0 to 1 or 0 to 10. This is, you can use it using the array job. The other one, which is sbatch dependency, and this is if there is any dependencies, you know, required by your job. And this is, for example, you can specify if there is any dependencies, you know, needed for your submitted jobs by using the command found sbatch -- dependency. And for example, if there is a dependencies after completion, you can specify that after OK colon and the job ID. If there is, you know, if it's not successful job, so you can do, you know, after not OK and the job ID. You can use those. I mean, it's rarely happened to be used, but you know, sometimes if you use it, like, you can use those options in your submission command. So and now let's like submit our job. So our job is ready for submission. How we can submit it to the Slurm? So we can allocate the, you know, and run the job for, you know, for the submitted jobs. So the command is called sbatch. Sbatch is the command to submit your job, and the name of the, you know, submitting job file, which is here we have it serial.sh. So after we do this, let's do this. So directly your job is submitted. Our job is submitted to the batch system and it's assigned to the job ID. This is the job ID that I was mentioned. So there is another command called sq. Sq, it will show you all the jobs that are running on the cluster, or all the jobs are submitted to the cluster. There are many actually. So if I do clear and if I do sq, there is a command that can have like another parameter -u, which is the user, and my username, which is Tanash. This is will specify the name of the users that is, you know, submitted job. So I do have just submitted one job, and now, as you can see here, there is st, which is the status of the job, which is r, that means running. Then my job is running. And on the other hand, so this is the job ID that's already assigned. And the partition is, you know, usually your partition, if it's batch, unless you have a reserved partition or you specify another partition in your submit scripts. So this is the partition that you run the job, and this is the name of the job, as I mentioned there. I didn't put %J. If I put %J, then it's gonna be like the name of the job. Then after that, the job ID. This is gonna be the job name, and who's the user? This is me, and the time is running right now is 31 seconds, and this is how many nodes reserved, which is 1 node, and this is the name of the node it's running on, which is C181. If I do SQ again, as I can see here, so the job is not running anymore. It's already disappeared. That means usually your job is already completed and it's already run. Either it's successful running or it's failed running. And if I do ls, you can see here, as we specified in our submitting job, we specify an error file and specify an out file. As I mentioned, that the out file is going to be the output of your program, and the error file if there is any error. And because we use %J, it attached the name serial with the %J, the number of the job ID number in my job. So if I want to see, I can do nano, for example, serial dot 64 dot, for example, error. If there is no error and my job runs successfully, usually I will see nothing in here, which is good actually. That means our job usually run successfully. To see the output of my program, so if I do nano serial dot 64 dot out, this is usually the output, and this is the output of my job after completion. So any questions so far? I hope this is clear for everyone. So now let's submit our jobs again. So if I do batch, if I submit my job again, if you submit it to your job, and if I do SQ-U Tanash, so I can see my job is running. So if you have your job running, sometime you want to cancel your job. So you can cancel your job by using the command as cancel and the job ID, which is 640761. If I do this one, if I do again SQ-U Tanash, and I see the status now it's not running. So if I do it again, so it's not running because I already canceled the job. So on the other hand, because it's running, you can see the error file again, and the output file again. But the output usually doesn't have the output because let's see, nano. Look, as you can see, the output is not here because we already canceled the job. So if you can cancel your job and using the command as cancel. So also there is an argument that you can use, for example, dash name, the job name, as I mentioned. There's the partitions for your partition, users, username, the states of your job. And usually the status, it's running, which is R. As you can see here, for example, here it's running, the ST is running. Sometimes it's going to be like, you can see it usually PD, which is stand for pending. Pending, that means like your job is not allocated the resources yet, especially if you are asked for, lots of resources, and usually it's going to be pending. And that means like your job is waiting for the resources to be allocated. And when it's allocated, it's going to change from PD to R, which is running. And sometimes it's suspended if there's usually, a usage quota or, some other problems, usually it's going to be suspended. So usually it's not going to be running. And we already talked about those, like job ID when you use SQ. And usually if you use SQ, you will see, for example, SQ command will show you all the jobs that are, as you can see here, those are running jobs. And for example, here is
PD. And if you do SQ, you will see all the jobs for all the users submitted. But on the other hand, if, for example, try to cancel one of those, you can't because it's not your username. So you can just cancel using the cancel command the jobs who are related to yourself or assigned by yourself. If the user is not yours and you try, for example, to cancel this job, it's not going to be canceled because this is not your job and you can't cancel. You can just cancel the jobs that are related to yourself, but you can view them and you can see them and you can see how many of them. Usually you don't need to do that, but usually you need to do SQ and -u, which is your username, and you can see how many jobs. So till now, I have no jobs running on the cluster. Okay. Common reason cause, sometimes like there's a dependency, there is a node down. You can see those in the status of the jobs. If there's, for example, partition down, there's a maintenance. Usually when we do maintenance, you will see usually like requested node not available or, you know, partition down. If we do usually, you know, a maintenance for our cluster, and if there's any problem with the nodes, you see some of those, you know, errors on the node section. On the other hand, there's a priority. If there's priority jobs that more than your priority job, then you're gonna see the status of the node for priority. Or if there is, you know, if your job is, you know, if you submit jobs who was dependent on other jobs, so you will see its dependency usually, which is your jobs are waiting for a dependent job to be completed first. Then it's going to be, you know, assigned for your job. SQ has options. We already do -u, which is the username. You can use -j and job list. For example, if I do again, if we submitted our job again, and if I do SQ -j, which is I can specify the job number, and I can see here the status of the job number itself. So if you have 100 jobs and you want to specify, instead of having a list of your 100 jobs and just try to find it, so then you can do just, you know, SQ with the job ID, and even you can do 1 job or 2 jobs or 3 jobs at the same time. If you want to see part of the jobs that you submitted in a specific partition, you can do using the -p parameter. Or if you need to just see, for example, I want the status of my job or all the jobs of myself. Like, for example, I'll do, for example, -u Tanash, and for example, -t, which is the status of the job which is be running. And sorry. And as you can see here, there's no running because it's already, like, you know, finished. But if I submit the job again, and let's see, as you can see here, so the running jobs is, you know, I have just 1 job is running, and I can see the status. For example, if I have 1,000 jobs, you know, submitted to the cluster, I want to see just the pending or the running. The pending, I can see PD. I don't have any PD. I don't have any pending. But if I want to see just the running jobs, I can do running jobs. So those commands are very useful and very, you know, helpful for you, you know, to monitor your submitted jobs on the cluster. There is a -i. A -i, you can, for example, if I submitted a job to the cluster, I'll submit the same job again. And then after that, if I do -i 2, this is gonna help me to repeat, instead of doing SQ every time, just this is going to be automatically repeat the command every 2 seconds. You can specify 10 seconds, whatever. So after 2 seconds now, it's gonna again, you know, run the job. This is for monitoring your job. For example, if I have a job running, I want to see when it's, you know, directly when it's finished, or see if it's pending when it's running. So I can, you know, specify, and this is can be doing using the -i parameter. --start will, you know, pending jobs are scheduled to start time. So you can see, you know, the start time, or when your job is going to be started usually. or the expected time for your job to start. And this is very helpful for, you know, the pending jobs. If you have pending jobs, and you want to start the job, know when this job is going to be start, you can use the -- start option. I'm so sorry for taking more time. I think this is very important for you guys to know. And now you can do this, you know, later, which is you can clone the same example, and we already did this one together. Now we will talk about the interactive jobs. We already talked about, you know, SBAT jobs, and now we are talking about interactive jobs. Interactive jobs work if we want to do interactively, to run jobs interactively. Now, right now, as you can see, I'm on the Swan, right? And I am in the login node. So now if I want to run any jobs, for example, if I want to have, you know, hello world.c, for example, I want to run this application interactively. If I have a C program, Python program, R program, whatever program you want to run interactively, if you run it directly where you are right now in your work or in your home directory, that means, and if you look at you here, if you see login node, that means you are running it from the login node, which is absolutely wrong. So you don't need to do that. So what you need to do, you need to reserve some, you know, some resources from the cluster, and then after that, when those resources are assigned to you, you can run those applications interactively. And how we can do that? We can do that. What does it mean here? Like here, like we are in the login node. After we request for some resources, we're going to be assigned some resources from the worker nodes, which is we can run whatever we want safely without our jobs to be killed. So to do this, we will use this command. This command is very important for you to know, which is the command srun. Srun, it will, you know, asking for an interactive job and assign how many nodes we need. For example, I need one node. How many CPUs? 4 CPUs. How much memory? I want 1 gigabytes, or, you know, 1024, because the default is megabytes. So this is going to be the megabytes. And the time, how much time do I need? For example, this 3 hours. And I need this to be, you know, this is PTY, which is stands for, you know, pseudo terminal mode, which is where my output and input is going to be directed. And usually this is going to be to the shell. So if I run this command, you can actually specify, you know, resources as you want, but like for a limited space, so limited on how many resources and the availability of the resources that we have. And usually if you ask for more resources, you're gonna be waiting much longer than if you ask for less resources. So that's why right now we are asking for 1 node, for example, and 4 CPUs and 1 gig of memory. And if I do enter, so as you can see, srun, it assigned a job for myself, and I'm in the queue waiting for the resources. That's what I'm saying. If I ask for more resources, it's going to be waiting more. So here, it's already, you know, assigned the resources for myself. And as you can see, it gives me a job ID. And what you notice here, I was here in the login node, and now I've been changed to the one of the nodes, which is C1415. Now, if I run whatever I run, so I'll be in the same location. Look, nothing happened to me. So I am in the same location. I am in my work directory. But the thing is, instead of running the job on the login node, now I'm running it on the node C1415, which is one of the worker nodes. And this job is going to be running for how many hours? 3 hours. If I want it more, I can specify it more. So now, if I want to run our jobs, whatever jobs interactively, I can do it safely instead of doing it on the login node, which is going to be harm, you know, our resources, and your job is going to be killed. So don't do it in the login node. If you want to do interactively, just do it using the srun command. Specify the amount of the memory and CPUs that you want, and run your job. And already I have hello world. If I want to do hello world, so I can compile it. I already compile it. If I want just to, run it, so I can run it, and I can see the, hello world, the output of myself. I can do module load again, for example, R, and then after that I can, run R and work with R, whatever I want. So I'm now working with R, but I'm doing it on the worker node. So if I want to exit the worker node and just I finished and I have more time, so I then just do, if you do exit, you just you will be exited and you will be coming back to your login node. And this is very important for you to know. Don't run interactive jobs on the login node. Usually you just do reserve for resources using the srun command interactively, and do whatever you want interactively over there and run your applications interactively. There is another thing I want to mention in here. So sometimes you want to use the same thing, but you are waiting for lots of the resources. If your resources that asking is a few, you can specify a queue. This is we already specify a queue for shorter jobs, which is called short queue. So this queue, you can specify it by the option --QoS, which is stand for quality of service, which is the name of the queue short. So if you specify for the short, your job usually is going to be, the allocated resource is going to be, specified to you faster, but there's a limitation. So the limitation for using a QoS short, which is the maximum is 6 hours for your runtime for your interactive jobs, and you are assigned you can run 2 jobs with maximum of 16 CPUs. You can't ask for more than 16 CPUs for your interactive job, and you can't ask for more than 256 CPUs in the short jobs for all users. So it depends on the all users and the user itself. It depends. So for example, if I do the short here, so it's already, as you can mention, look how fast was it for assigning the jobs. So I'm now in the C1415 node. I can do whatever I want. I can start like with running my jobs, R, MATLAB, even my analysis, so I can do it on the interactive job. Again, if I use here, for example, 300 gigabytes memory, that's too much resources. And for example, here I ask for example, 24 hours time, and I ask for 8 nodes, and ask for example, 32 CPUs, then unable to allocate resources because those resources are more than what's they can configure for myself. So usually, like, this is even if you ask for more, this is going to be probably like usually interactive jobs is not for heavy jobs. So if you want to submit jobs, then use batch. Then you use batch for your submitted jobs. So usually here it's because of the memory. Whenever you ask more, it's going to be, as you can see here, it's going to be taking much more time. Just I want to show you like the more time that's requested here. You can be waiting a lot if you are using too much resources. So what I recommend you is just like use manageable amount of resources for your interactive jobs and start working on it. The exercises we already talked about it. So here's just like ask you to allocate some resources for interactive jobs using srun command. Here is like just choose one CPU and 10 gigabyte of RAM, or, you know, there are some options you can use. We already did that. And then after that, you know, run your R or MATLAB, or, you know, we have already done this exercise. Workflow tips. So, you know, there is a comment I just want to mention here. There is always, you know, our documentation, running jobs. So if you can just write or Google it, HCC UNL running jobs. So you will have all the information that you need, and we already talked about. On the other hand, we didn't talk about, you know, as account. As account is, you know, is another command that you can use. It gives you, for example, some information about the job you already, or you are running, and you already run on the cluster. For example, you can say here, there is one of the jobs we have already run. For example, this is one of the jobs. So if I do, for example, ACCT, which is S account -J, and the name of the job. So as you can see, here's gives some information of the running job. This information is from the Slurm, the scheduler, and the partition I've run this job run into is called bash, and the account, which is the group name, and the status of the job is completed. But sometimes I want, you know, more information about my job. So I can do, for example, format elapsed, and I think you can see max RSS also, max RSS. So this is gonna give you the information about how much time does it take for your job to be running since the time you submitted your job. So it takes 1 minute and 2 seconds for my job. And this is the amount, the max RSS is the amount of, you know, memory that my job used, which is in kilobytes. So this gives you, for example, an indication if you wanna to specify how much amount of memory and time you want to run for your submitted job. If you run a small job, you do as account, you do, you know, how much time does it take and how much memory it used. Then after that, see how many times my real submitted jobs is gonna be. For example, if it's 10 times, then probably it's gonna take 10 minutes. And if it's 10 times, it's gonna be 10 times the amount of the, you know, memory that it takes, you know. Overestimate a little bit is okay. But, you know, overestimating a lot is gonna, you know, waste the resources, and is gonna, you know, make your job wait on the queue for a long time. Again, don't forget to use man or help command for any of the commands that we have already talking about. Also, you can contact us using the open office hours, or email us as hcc-support@unl.edu and create a ticket if you have any problem. And if you have any questions also, please let me know. Always Google, and, you know, we will talk about, you know, more useful stuff to, you know, procedures for you, like tomorrow probably, and other sessions. And thank you so much. If you have any questions, please don't hesitate to ask. And again, please don't forget, you know, before you leave, to fill out our feedback form, so we can get, you know, an indication about